classes. Yeah. So now to understand Java in detail, whatever we have seen was an overview of classes, methods, and everything like the several advantages of Java, several branching statements, the for loops and looping constraints, escape keywords basically. So let's get a more detailed idea about what Java methods and classes are. So let's proceed to our next slide. So classes are definition. So as I said, Java is a pure object-oriented programming language, and so everything inside Java must be encapsulated inside a class. So what are OOP paradigms basically? Let's uh, have a look at them. So classes are nothing but a blueprint of your objects, or you can say they are your object definitions. In classes, we define everything that our program or our instance needs access to, and using object we can access that classes. So class is one and objects are several different entities of that class. So let's understand it first. So what is OOP? It is object oriented programming. The codes are built from objects. Java, these are clone classes. So each class definition is coded in a separate Java file. That is true. And name of the object must match the class and object name, as we will be getting deeper into the programming into our later lectures. So that will help you understand how Java is programmed actually, and how the things are done exactly in Java to have an error-free programming environment. So these are the three basic important principles of object-oriented programming. That is encapsulation. It means object hide their functions and data basically, and you just access to you don't have access to the internal processing. You just have the access to the real-world data that is made public inside the class. And what is inheritance? Inheritance is nothing but each subclass inherits all variables of its superclass. So in Java, you have that facility to reuse the code of your previous parent classes. So we are going to see what is inheritance and what is all the basics about uh, Java basically into our succeeding lectures. So now polymorphism. Now what is polymorphism? I have explained you at the beginnings, like uh, many forms. So poly means many and morph means form. So one action and one command and many actions. So it is nothing but an interface, same despite different data types. Now we are going to jump into how the classes and methods are declared inside Java. So basically class in Java is declared in this manner. So we write class name, and inside that the different variables that are declared over here, and inside that the functions that are present inside this class. So in this is the actual, you can say, a structure of how class is declared in Java. So a class can contain different variables and functions to access those variables. So the in Java functions are called as methods. So now we are going to use that convention. We are going to say methods for functions. So what is a method? Method is a named sequence of code that can be invoked by other Java code. So a method takes some parameters, it performs some computation, and then optionally returns a value. So if it is a void, it won't return a value. If except a void, it has some return type, it will return a value. So methods can be used as a part of an expression statement, basically. So how a method works is a short brief, or you can say one line description or one line example is given over here. So public float convert Celsius, float times c, return times c, and in this way the return function of the return works with a function. So we know that here we are sure that the function is going to return a float value. We compute it, we have some decimal value, and the return type of the function is given here as float. So it is quite important to note the signature of each and every function. If you want to return a specific value, that value must have some, it must match with some of the primitive data types, and that can be used as the return type with your function. So what a method signature is basically. So method signature specifies the name of the method, the type and name of each parameter if present, the type of the value or object returned by the method, the checked exceptions thrown by the method, various method modifiers, modifier type name, etc. So here we need to uh, keep this noted, that how or what a method signature contains. So here we see the access specifier associated with that method, the return type of the method, the name of the method, and the parameters. Same over here. So the signature of the method may change as per the requirement, and yes, so they can vary from program to program. So we must know how a method is declared basically, and we will be getting a dive into our succeeding lectures on method declarations as well. So what are public and private? These are nothing but the access specifiers in Java. So not only public, private, we have protected and default. So the default access specifier in Java is known as default. So when we will be learning packages and interfaces with Java, we will be getting to know what these access specifiers are used for basically. So methods or data may be declared public or private, meaning they may or may not be accessed by code in other classes. So I have noted some good programming practice for you. So it is keep the data private and keep most of the methods of your classes private. So what I, or you can say a general good practice is, all the data inside a class must be declared inside the private part, and all the methods should also be into a private section basically, and only those methods that are necessary to be made public should be declared inside the public section, so that they could access your so that gives you an additional security of encapsulation, that you only allow certain functions through which to communicate to your class, and through that functions you can access the private variables inside your class. So this is actually a convention, a good convention to be followed. A well-defined interface between classes helps to eliminate errors. So how do we use objects? Objects are nothing but the instance of classes, and to declare an object we just write in this manner. So a class name, object name equal to new class name. So new operator allocates a memory to that class. So whatever that class contains, maybe the data type, maybe sorry, the data members, maybe the member functions, all the memory associated with them are allocated inside this plum object. And we are declaring a new variable over here, and whatever methods we want to access inside this class, as usual we access it using the dot operator. So dot operator allows you to access the public data methods inside the fruit class. So you must note one and not the private or protected one. So protected are that comes into picture when we will be learning inheritance concepts. So what are constructors basically? When we come into classes and object sections, so constructors are nothing but a type of special methods that doesn't have any return type. You can note it down. Maybe it is not displayed on this slide. I want to explain you and give more focus on my these words basically. So constructors are special member variable member methods of the class. They don't have any return type, they may have different signature, they may have parameters, and they don't return anything, and they are called automatically when the object is created. So there is no need of explicit you can say initialization or calling of constructors. So what happens is, when I create this plum equal to new fruit, so the constructor gets automatically called when I new. So this statement invokes a constructor method with which you can set the initial data of an object. Let me give you an example for this. Suppose I have a class named shapes, and I want to calculate my value, or you can say I'm gonna work with the value of pi and the value of uh, like for a default if we want to set it. So what I can do is, instead of asking from user again and again to enter the value of pi, or setting it myself into the later stage of program, I know some of the default values must be set at the time of object creation. Okay, so such things I will put into my constructor. So whenever the object is created, the initial default value such as the value of pi 3.14 will be set inside some variable, and that variable will be used throughout the program. So no need to worry about changing its values or assigning it in the later stage of your program basically. So in that way it works. And you may choose several different type of constructors with different argument lists. So as I said, the constructor can also have different signature as that of method. Just the important key things which I have like asked you to note, only we have to follow that. So what is overloading? Basically it is again a part of object oriented programming. So overloading means nothing but same method names but different signatures. So as said, it can have several versions of a method in class with different types or number of arguments. So by looking at argument, Java decide which version to use. So it is quite simple. You can use several different methods with same name inside a class, but its signature should be different. So signature can be the return type or different arguments. So let's now get a brief into whatever things we have done. So before proceeding ahead, I would want to tell you before jumping into the programming practice about what this JDK thing is basically. So Java C is nothing but Java compiler. Java is Java interpreter. JDB is Java debugger. So whenever we want to compile our Java file, we write Java C space our file name dot Java. Whenever we want to execute our Java file, we write Java space our file name, and JDB is nothing but a debugger that you can use to execute or learn your code or read execute your code line by line. Applet viewer is a tool to run the applet. So gradually into our next sections of Java programming, we are gonna see what applet is and how to run that applet file. So Java P is to print the Java bytecodes. Java Prof is Java profiler to get different stats and monitoring about how your code is performing. Then Java Doc, it is the document generator. Automatically, the document of your code will get generated. Java H, it creates a C header file. So basically, at the initial stage, we are gonna need only this two, that is Java C and Java. So you can note this down. Now, coming to the last part of our introduction to, or you can say the fundamentals of a Java programming, is stream manipulation. So what are streams basically? Let's understand them first. So stream is nothing but the files used to perform the basic input and output operation. So like or language, we when we develop program, it is necessary to have some kind of database at the backend. So maybe in terms of file systems or SQL databases, or you can say some kind of external data source for our program to work upon. So streams allow you to do that basically. And there are basically two types of stream: input stream and output stream. So input stream is the input to your program, and output stream is printing the results out from your program to a file or your screen maybe, or a console. So for your Java program, a console is also you can say a type of file. It reads it as a file. So when you write system.out.println, what happens is the result that is produced by your compiler is thrown or put onto your file. And when you want to read something from the user, so we write we of course we need to instantiate the buffer readers or input stream reader, or we can use the scanner libraries for reading from the user. And so all the definitions, or you can say the implementation of stream manipulation, is done inside those libraries. So for example, let's not get that deep into the things as of now, and let's go ahead with this example. So how to read from a file. So just open a file, my file.txt, for reading. So in Java, that is achieved using this inbuilt library, that is input stream. We create this object and new file input stream, and we write the file name. So to open a file for writing, we have to create the object of file output stream, and we open it for writing. So just we have to follow these conventions. Like if you want to read a file, we create the object of input stream. If you want to write something, we create the object of output stream. This is a short code of how you can display the file content. So I may not explain it in that detail, because in the succeeding lectures we are going to see how to do this step by step, and getting up to speed with working with files and everything. So you can just have a look, and I will explain you certain things. So as we want to read this file, we create a file input stream and give a file name. We create a buffer, and inside that we store all, because whatever the data that is coming from the file will be in the form of byte stream. So we read that byte and store it into our buffer system.out.write, and ultimately we print that buffer basically late into, you may print that buffer whatever the thing is read from the file, and if the read is failed, if that file is not present or some kind of exception occur, we print that error. So this is just a short code defining how the files are read. And filters, once a stream has been opened, we can attach filters. So filters make reading and writing more efficient. So the popular filters that we are going to use ahead into our succeeding lectures is nothing but data input stream, data output stream, and object input stream and object output stream. So for objects we use object input stream and output stream, and for basic types we use data input stream and data output stream. So how to write a data to a file using filters? So similarly, same function. We first create output stream, then we use this filter data output stream. We pass the output stream object, file output stream object to the data output stream, and then we write something into that file and we close it. So when you open this file stuff.dat later, maybe from your file system, you will see all this thing written into that file. Reading data from a file using filters, same thing. So we create a file input stream, we pass that object to data input stream, we read it and print it line by line using this system.println dis.read double. Now what is object serialization? So when we write objects to a file, that in that scenario this concept comes into picture, that is object serialization. So for object serialization we use object input stream and object output stream. Why this is necessary? So let me give you an example. If you are working on a network application basically, and we have may contain object of a class that may contain a lot of data. So that may be in different types, maybe primitive types or user defined data types. So when we transfer your object to a file or on network, it is necessary to convert that object into a byte stream, and that is achieved using serialization. So we use the object input stream and object output stream classes, or these are also known as filters, to serialize your object. So that is again simple to understand. First we see which file we want to write into, and then we create object output stream, we pass a file output stream to it, and we just simply write s.write object d. So this is the object of one inbuilt class, that is date, and we write into it. So the object gets returned in a serialized manner into that file. Similarly, to read, we create input stream object, we create a object input stream object, and file pass that file input stream object to object input stream, and then print the contents line by line. So with this we have got up to speed up to what Java is basically by learning all the basic fundamentals. So I would once again like to summarize all the things what we have seen. So we have learned all the basic fundamentals of Java, starting from its pros and cons, basically why it is a platform friendly language, how the internal representation of Java is, how it converts the Java code into bytecode, and that bytecode can travel from platforms to platforms, and the execution could remain the same. So we also saw the several operators, arithmetic operators, relational operators, and logical operators that can be used for basic programming practices. Accordingly, we've seen different branching statements such as if statements, nested if else, and switch statements that could be used for several different programming operations, and which were quite similar to C++ in syntax. and most of the other programming languages as well. We later saw several different looping concepts using for loop, while loops, and do while loops. And succeedingly, we seen several escape keywords such as break and continue, how they can be used to take control of your looping and branching statements. And later, succeedingly, we saw how what are Java methods and classes. So how do we declare Java methods, and how the classes are declared, how they are used, so how to create the object of classes, how to create the array of objects, and what are arrays. Basically, we saw several different properties of array, the index conventions that are involved and followed while using the array formats basically. And in the later stages, we came to how the Java streams are manipulated basically to read and write files, and how the filters are associated to make the things work more easier. And finally, we saw how the Java objects can be transported from network or to files by using different filters again. So those were object input streams and object output streams. So these are all the fundamentals that we are going to uh, uh, actually see in detail into our succeeding lectures. So from the basics, like how the programming is done, how the program is created, how the input and outputs are processed, how the inputs are accepted from the users, then succeedingly doing certain programs on if else, and several different branching statements on looping conventions, and using several relational and arithmetic operators. We are going to see that, and after that, definitely we will be jumping on inheritance concepts. So all the types of inheritance will be covered into our succeeding lectures: the single level inheritance, the multi-level inheritance, hierarchical, and how the multiple inheritance is achieved in Java using interfaces, and what are packages basically. And after that, we'll be covering the polymorphism concepts inside Java, and ultimately we will be getting to know the multi-threading aspects, how Java supports multi-threading, and creating certain threads using Java. And lastly, we will conclude with learning applets. So thank you for watching this. Have a great day.